The Math Center presents Variance. In this presentation, we'll talk about measures of variation and understanding the meaning of variance, the relationship between variance and standard deviation, and finally, solving a question on variance. Measures of variation tell us how a data set is scattered or spread. They are also known as measures of dispersion or measures of spread. There are three measures of variation which we shall discuss, and they are variance, standard deviation, and range. Variance is a statistical measure of variation of measured data from the mean value of the data set. In other words, it's measuring how far the data values are from the average value of the set. Most of the time, we'll be calculating variance for a sample, which is the sample variance. We can also talk about a population variance, which is the variance from a whole population data set. There is a relationship between variance and standard deviation. We see below that the variance is the standard deviation squared. So when we have a standard deviation, we can multiply it by itself to find the variance. If you know the variance, then you take the square root to find the standard deviation. We use the lowercase letter s to indicate the sample standard deviation. If we raise s to the second power, or lowercase s squared, that is the sample variance. For the population standard deviation, we use the lowercase Greek letter sigma. Square that, and it gives us the population variance. Let's look at an example question. Here we have blood pressure measurements for 14 different second-year medical students at Bellevue Hospital, where they're asked to measure the blood pressure of the same person. The systolic readings in millimeter mercury are listed below. What do the measures of variation suggest about the accuracy of the readings? So you have readings of 138 millimeter mercury, 130 millimeter mercury, 135 millimeter mercury, and so on. These are 14 different readings measured by 14 different students, measuring the blood pressure of the same person. Let's look at how these values vary by measuring how spread out they are. We'll start with the range. The range is the highest value minus the lowest value. On our list, the highest value is 150 and the lowest value is 120, so the range is 30. This gives us a rough idea of the spread, but doesn't tell us much about what is happening between the max and the min. The variance and standard deviation will give us a better idea about the spread. Before we find the variance, let's look at the formula. To find the variance, we need to find the difference between each data value and the mean. We will then take each of these differences and square them. The sigma symbol says to add each of these squared differences up. And finally, we divide by the number of values in our data set minus 1. So first of all, you'll find the mean of the set. You do this by adding up all the data values and then divide by the number of values, which in this case is 14. When you do that, you should get approximately 133.93 millimeter mercury. To find the variance, it helps a great deal to organize your data into a table like this. The first column has each data value listed. The second column is the frequency, or how often each data value appears. For instance, 4 students measured the blood pressure as 130, so the frequency for 130 is 4. The next column lists the difference between the data value and the mean. You just subtract the mean from the data value. The next one is the square of the difference. Finally, you multiply the squared difference by the frequency to give the values in the last column. For instance, in the first row, we had 194.01 as the squared difference and a frequency of 2. So multiply 194.01 by 2 and get 388.02 in the last column. To find the variance, you should total up all the values in the last column. Our total is 1062.92. Now divide this by the number of values minus 1. In our case, we have 14 values, so we will be dividing by 14 minus 1, 13. Using the formulas, you have the sum of the last column on top, which was 1062.92, and the number of values minus 1 on the bottom, which is 13. When you put this into your calculator, you have the variance is 81.76 millimeter mercury squared. Notice that the units on variance are the square of our original units. The standard deviation is the square root of this, so taking the square root of 81.76, we get 9.04 millimeter mercury, which is the same units as our original measurements. So what can we conclude? We found that these values varied from 120 to 150 millimeter mercury. The standard deviation is large, considering that we would like blood pressure measurements to be consistent, so the measurement is not accurate. Thank you for watching this presentation on variance.